In this video, we're going to talk about solving quadratic equations by factoring. And the learning targets of this lesson are what the title says exactly, solving quadratic equations by factoring. We're going to be able to interpret solutions of a quadratic equation, and we're going to be able to create quadratic equations from solutions. So, before we talk about any of that, I want to talk about what's the difference between an expression and an equation. Well, an expression, like we've been talking about, looks like this, and an equation looks like this. These are both quadratic. One's a quadratic expression, the other's a quadratic equation. When we see something that looks like this, we want to factor it. That's what we want to do to it. But when we see something that looks like this, we don't just want to factor it. We also want to solve it. How do I look at this thing and know that I want to solve it, not just factor it? I know because it has this equal sign. When I have an equation, and I know I have an equation when I see an equal sign, that tells me I don't just want to factor it, I want to get x by itself, I want to solve. When I have a variable and an equation, I want to solve. So the difference between an expression and an equation is that an expression has no equal sign, and an equation has an equal sign. And when I see an equation, I need to make sure I'm solving it as well as factoring. You can remember that equation has an equal sign by it starting with equa, which is almost equal. All right. What do I always see in a quadratic expression and equation? Well, looking at these two examples, they have the same exact numbers, but what I always see in a quadratic something is x squared. So if I see x squared, I know I have a quadratic something. X squared is the key for quadratics. If I see x squared, I know I have a quadratic equation. The graph of that thing is going to look like a parabola. We talked about this before. In case you forgot what a parabola looks like, it is a U shape, like that. Or you could have an upside down U shape, like that. So that's what a graph of a quadratic equation looks like. On a graph, the solutions to a quadratic equation are called, and so what you would find x is equal to when you solve this thing, those are the x-intercepts. So that makes sense because you're asking, what does x have to be equal to for your output to be 0? Quadratic equations, you always want them to be equal to 0. When you solve them, you're going to get your x-intercepts. So that's what's going to make y equal to 0. Whatever x values give you y is equal to 0. Your output is 0. Another thing that we call x-intercepts is roots. So they're called roots, and they're also called zeros because they're what makes the output 0. So those are the three different things that they could be called. They could be asking you for when they're asking for the solutions to a quadratic equation. There are three different types of solutions you can have. So you could have two solutions, you could have one solution, or you could have no solution, which seems like always the case to everything. Two solutions. If solution means x-intercept, that means I have two x-intercepts. That's two places where the graph intersects the x-axis. So maybe it intersects right here. That's on the x-axis. And I need two, so maybe the other one intersects there. And now I have a parabola connecting them. That is an example of a parabola or a quadratic equation with two answers or solutions. I didn't have to draw it like that. Whoops. I could have also made it look like this, as long as it's intersecting in two places. For one solution, that means I'm intersecting the x-axis at only one point, which means that point is that point is my vertex. So it's going to be the vertex of the parabola if I have one solution. And then if I have no solution, that means I'm not going to be on this axis at all. I'm not intersecting it. But no solution doesn't mean no graph. It just means I'm not intersecting this x-axis. And I can do that. Maybe that's my vertex. And my parabola goes like this. Never touches the x-axis. All right, so those are what your graphs would look like for two solutions, one solution, no solution. Before we get into the steps of solving a quadratic equation, real quick, I want to remind you guys of the zero product property. The zero product property says if I have A times B is equal to 0, I know that one of those two things has to be 0. Either A has to be equal to 0 or B has to be equal to 0. For me to get an answer of 0, one of the two factors has to be 0. So maybe I have 0 times 4. Stop texting me. Maybe I have 0 times 4, and that's equal to 0. Maybe I have 5 times 0. One of those things has to be 0 for that answer to be 0. So either A is 0 or B is 0, and that is my zero product property. I'm going to highlight this. It's important. All right, so now factoring to solve quadratic equations, the steps to doing that. First step, well, here's an example of a quadratic equation I want to solve. So I want to solve this quadratic equation, x squared plus 2x is equal to 8. That's what I want to solve. I know it's a quadratic equation because I have x squared and I have an equal sign. All right, step 1 though is to get 0 on one side of the equation. So we could use that zero product property we just talked about. So get 0 on one side, on one side of the equation. So I want to get 0 on one side of the equation because, well, I'm looking for my zeros. I'm looking for the things that make y is equal to 0. Because I want to find the x-intercepts. That's my solutions. So right now I don't have 0 by itself on one side here. I have 8 on one side. I could very easily get 0 by itself on the right-hand side by taking away that 8. If I do that to the left, if I do that to the right, I have to do that to the left. And I'll end up with x squared plus 2x minus 8 is equal to 0. Got 0 on one side of the equation. First step, done. Second step, factor. I know how to factor this thing on the left now. We talked about it. It's a quadratic expression. It could be factored. So I know I need two numbers that multiply to -8 and add up to 2. Those two numbers are +4 and -2. So instead of writing this as is, I'm going to write it as x plus 4 times x minus 2 is equal to 0. Done with my second step. Third step, I'm going to take this and I'm going to use my zero product property and I'm going to write two equations that I can solve. So third step, write two equations using the zero product property. So I know that if this is A and this is B, I'm multiplying to get 0, then either A or B has to be equal to 0. So either x plus 4 has to be equal to 0 or x minus 2 is equal to 0. Wrote two equations, done with my third step. Last step, as always, solve those equations that you wrote. So I'm going to subtract 4 on both sides here, add 2 on both sides here, and I get that x is equal to -4 or x is equal to 2. And that's my answer. All right, so let's apply this to a different example. Example 1, this should say equal to 0. I hope it does on your sheet. All right, so I have an equation here, x squared minus 18x plus 40 is equal to 0. That's the example we started with. We're going to solve this thing. So I need, first of all, this has a coefficient of 1 in front of the x squared, so I know I can use the diamond to get the factored form. I need two numbers that multiply to 40 and add up to negative 18. So those two numbers are negative 20 and positive 2. So instead of writing this, I'm going to write x minus 20. Whoops. Why did I write that so stupidly? X minus 20 times x plus 2 is equal to 0. Well, like I said before, if this is my A and this is my B and this is equal to 0, then I'm going to use that zero product property. Actually, sorry. That says A times B, if A times B is equal to 0, A is equal to 0, or B is equal to 0. To write my two equations, x minus 20 is equal to 0, or x plus 2 is equal to 0. And then I solve those two equations. So in the left equation, I'm adding 20 on both sides. In the right, I'm subtracting 2. And I'm going to end up with x is equal to 20 or x is equal to negative 2. And those are my answers. The way this looks on a graph, if I graph it, I'm going to sketch a little graph here. I have 20 is an x-intercept. Negative 2 is an x-intercept. So I have negative 2 and 20. This is not to scale. Because I have a positive coefficient for x squared, I know this is an upwards parabola like this. And because that is not to scale, I'm just going to label negative 2 and 20. That's what example 1 looks like. All right, for example 2, I want to find, I'm using my diamond, to find two numbers that multiply to negative 4 and add up to negative 3. And those two numbers are negative 4 and positive 1. So I'm going to rewrite this as x squared minus 3x minus 4 is equal to 0. Oh, no, I just wrote the same thing. I'm going to take that and I'm going to rewrite it as x minus 4 times x plus 1 is equal to 0. I just took these numbers and I put them in my factored form. And then I know that either this is equal to 0 or this is equal to 0. So I'm going to write those two equations, x minus 4 is equal to 0 or x plus 1 is equal to 0. I solve those two equations and I end up with x is equal to 4 or x is equal to negative 1. And then to sketch the graph of what that would look like, the graph here, I know I have 4 is an x-intercept, and so is negative 1. And then I connect them in an upwards U shape because, again, I have a positive coefficient for x squared. All right, let's try example 3. So I have x squared minus 36 is equal to 0. I want to factor, solve, and sketch. I know that this is the difference of two squares, and I want to know, well, what is being squared in the first term and the second term. So I know I have x to the second power minus 6 to the second power is equal to 0. So that means that in my factored form, I have x plus 6 times x minus 6 is equal to 0. That tells me I can write two equations here. I know one of these two things has to be 0. So I can say either x plus 6 is equal to 0 or x minus 6 is equal to 0. And then I solve those two, subtract 6, add 6. And I got x is equal to negative 6, or x is equal to 6. Done. And to sketch that, what it would look like, I know that I would have an x-intercept at 6 and at negative 6. Then I would attach those in an upwards curve because, again, I have a plus 1 as the coefficient. I have a positive coefficient for x squared. Here, what I'm going to do first, when I factor this thing here, I'm going to take out a negative. So I only know how to, we only talked about factoring when we have positive numbers in front of the x squared. So if I see a negative, I want to factor it out. So I'm going to factor out a negative 1, and this is going to change to negative 1 times x squared minus 6x plus 5 is equal to 0. And then after that, I'm going to rewrite what's in parentheses, and this is going to be x, oh, I'm sorry, I have to talk about the diamond. So I need two numbers that multiply to 5 and add up to negative 6. And those two numbers are negative 5 and negative 1. So I'm going to rewrite this as negative 1 times x minus 5 times x minus 1, and that's equal to 0. That tells me I don't care about this negative 1 for right now because I'm solving. I don't care about it. If I were factoring and I didn't have the right-hand side of this, I would care about that negative, but it's not going to affect that either this is equal to 0 or this is equal to 0, because one of the factors has to be 0 for the answer to be 0. Negative 1 is not 0, so I don't care about it. X minus 5 is equal to 0, or x minus 1 is equal to 0. One of those two things, those two unknowns, has to be 0. So I'm going to add 5, add 1, and I'm going to get that x is equal to 5, or x is equal to 1. Those are my answers. And then if I sketch the graph of that, I'm going to have an x-intercept at 5 and an x-intercept at 1. But because I have this negative 1 in front, because I have the negative coefficient, I know that this is going to be a downwards parabola. So instead of upwards, I'm going to draw it like this. All right, let's do the reverse. So I want to find a quadratic equation with zeros. X is equal to negative 2 and x is equal to 4. So I'm starting down here. Oops. I'm starting down here and I'm working my way back up. So the first thing I'm going to do is I'm going to say, well, x is equal to negative 2 or x is equal to 4. Next thing I do is write equations that are equal to 0. So I'm going to turn these into equations where I have 0 on one side, which means I'm going to add 2 on both sides here, and I'm going to subtract 4 on both sides here. That will get me 0 by itself. On the left-hand side, on the left equation, I'll have x plus 2 is equal to 0, or on the right-hand side, I'll have x minus 4 is equal to 0. I have now two equations where 0 is by itself on one side. I have an expression equal to 0 for both of those. Next step, I want to multiply those two things together. So I want to multiply the things that I have on the left-hand side. So I want to multiply x plus 2 times x minus 4 and set that equal to 0. From there, I just FOIL, and I get what I get. And when I FOIL this thing, and I like to use the area square, because it makes me happy, I'm going to do x and 2, x and negative 4. X times x is x squared. X times 2, 2x. Negative 4 times x, negative 4x, and negative 8. And then I add those together. X squared plus 2x minus 4x minus 8, which gives me x squared minus 2x minus 8 as my answer. And I want it to be an equation, so I want to set it equal to 0. That was the whole point. Oh, well, it already was. Set equal to 0. All right, for example 2, I have x is equal to 1/2 or x is equal to negative 3/2. First thing I'm going to do, I wrote that too big. Can I make this smaller? Yes, I can. Woohoo! Sweet. Okay. So I have x is equal to 1/2 or x is equal to negative 3/2. First thing I want to do is I want to get two equations with equations where 0's by itself on one side. So I'm going to, for the left-hand equation, I'm going to subtract 1/2 to get 0 by itself on the right-hand side. And that's going to give me x is equal to, JK, x minus 1/2 is equal to 0. Or if I add, on the right-hand side, I'm going to add 3/2 to both sides. And I'm going to get x plus 3/2 is equal to 0. So those are the two equations equal to 0. I have this expression equals 0 and this expression equals 0. So if I multiply those together, I'm going to get that's equals to 0. But before I do that, I hate fractions. So I'm going to get rid of the fractions here by multiplying by 2. And I'm going to get rid of the fractions here by multiplying by 2. And when I distribute, I'm going to end up with 2x minus 1 is equal to 0. Or if I distribute that 2, I'm going to get 2x plus 3 is equal to 0. And then I just bring those together. I multiply these two expressions. I have 2x minus 1 times 2x plus 3. If one of those things is equal to 0, then the product of them has to be equal to 0. I'm going to FOIL this. And I have 2x minus 1, 2x, 3. This is going to be 4x squared, 6x, negative 2x, negative 3. And collectively, I will have 4x squared plus 4x minus 3 is equal to 0. And I'm done.